All right, hopefully you got all these written down. We can go ahead and get started now. I don't think I missed anybody for attendance. All right. Today, though, I wanted to use the time to make sure that we get through the linear inequalities portion of this first part of our course, okay? We've talked about solving different types of equations, but we also have a different situation where we have something called inequalities, and I forgot to change this. It's supposed to be inequalities. I'll change that later. But as we deal with inequalities, what symbol did I put on here several times? Greater than, less than, right? Greater than or equal to, less than or equal to, right? These are things we're looking for. As I mentioned, I should have put inequality to begin with, but I can just kind of mess that up. But we have that there now. With that first statement, though, we need to be able to read an inequality. That's definitely an important part, right? So is 17 greater than 3? Right, and that's how we want to read, right? From left to right, 17 greater than 3. And what did someone use to remember that that's true? Who's a Pac-Man user? You do alligators. See, it's alligators or Pac-Man. Did someone use something different? I just remember. That's the main thing, though, that was interesting. All I knew about was the alligator. And then someone said, oh, my teacher taught me Pac-Man. And I was like, huh, I guess that makes sense too. All right, what about the next one then, though? 1.035 is less than 1.305. It's true. All right. How about letter C? Is 13 halves greater than or equal to 53 halves? No. What do we like about both the fractions? Common denominator, right? So we don't really need to worry about the denominator technically, right? So is 13 bigger than 53? No, right? So this would be a situation where it's false. Okay. How about the last one? Is negative 7.3 greater than or equal to negative 11? All right. In this case, it is, right? Because it's closer to 0 than it is the negative 11, right? So it's definitely true. We got to be careful because one thing that we're going to deal with this is the sign numbers. Okay. Now, I felt like that was just a great way to review, just to make sure, remember how to read inequalities. But how we're going to use them is with a statement like we see here in number 2. Right? Number 2, as you see here, I gave us an inequality solved. 2x minus 5 is less than or equal to 3. All right. But I gave you some x values. And if I said determine which values make the given statement true, what do we need to do with those x values? All right, we need to go plug them in, right, and see what happens, right? So what did someone get when they plugged in 0? Do we agree, though, with negative 5 less than or equal to 0? All right, 2 times 0 is 0. Minus 5 is negative 5. So that's definitely true, right? That one's nice, though, because a negative is definitely less than a positive number. Okay, focus on negatives is definitely a helpful thing to do when dealing with some of this stuff. What did someone get, though, when they plugged in negative 3 on the left side? But what is it? Negative 6 minus 5. So this one's negative 11, right? And again, a negative number, definitely less than 3 because 3 is positive. What happened when we plugged in the 11, though? All right. So you said 17. Do we all agree with 17 greater than or equal to 3, though? So plugging that in, right? 2 times 11 is 22 minus 5. That's where the 17 comes from. But 17 is actually bigger than the 3, so we would say false. Now, the 4 is a fun one, right? It's equal to, right? Because if you plug in the 4, we get 3 less than or equal to 3. So how do we interpret that? It's true, right? Because we have less than or equal to, right? It doesn't matter if it's the same because here it is allowed to be the same. Now, if I change it, though, and I put 3 as less than 3, is that true? Right? It's that because that equal to part, right? So that's one thing we want to be careful with inequalities, especially as we deal with it from our equation standpoint of recognizing the difference between just less than or having less than or equal to. Any questions or concerns with these two, though? No, the back door is open, just so y'all know. Now, the first thing I will say is from the solving perspective, inequalities, we've already covered how to solve. So solving the inequality for the most part is going to remain the same. There are some things that we have to watch for, and we'll make sure to look at that, right? But from the foundation of solving, we still want to make sure we're looking at simplifying when we need to simplify, and then using addition property and multiplication property qualities as needed. So like here, hopefully you see it's just X, right? So all we need to do is add the 7 to both sides. And at this point, it is solved for. That is the solved state that we're looking for. But the difference here is we're not saying that 3 is our solution. It should be 4, yeah. I was just testing you. That's all. So with that said, though, now that we have the correct value there, 7 minus 3 is 4, sorry. We don't have a situation where that tells me the single number to work with, right? This was linear because there was no exponents, no fractions, right? We can confidently say this is a linear inequality. But the way we interpret is going to be the part that changes, right? Before, if we had X equal to 4, that means, hey, if I plug in 4, it's going to be true. Now the inequality is going to tell me a group of numbers I can work with, right? So we actually now have what we call a set of solutions. So this is where we're going to deal with this. And we kind of saw this like polynomials when we had 3 solutions because it was cubic or something like that. That's technically a set of solutions. So when you get here, this is technically what we would use in set notation or set builder notation. It's like, hey, X is greater than 4. That tells us what we need. But what numbers would make this true? All right, so what are some examples, things bigger than 4? 5, 6, 7, 8. Right, what about 2 times pi? Doesn't that work? All right. We do something like the, say, the square root of 39. How do I know that works? What is 39 bigger than that we know the square root of? 39 is close to what perfect square? 36, right? So if the square root of 36 is 6, right, the square root of 39 is going to be a little bit more than 6, right? So we could have that confidence. So with that said, those are just 2 examples of solutions that are not integers, right? We could have used fractions as well, right? We could have said, hey, let's go ahead and use 19 thirds. Why do I know 19 thirds? Well, 3 divides into 19 6 times, right? So I know it's bigger than 4, okay? Because we have all these options now, we've been working with real numbers, right? We have another way to look at this, right? And that's going to be drawing a graph, right? So we're just going to do a number line graph. We only have one variable, so we're just going to draw one number line. And what number is an important number to put on that number line? The 4 is definitely the important one. Now, another good one to always put, though, is the 0. The 4 is the one we're focusing on, though, because that's the number that we got from our problem. I like to put 0 too, though, because it's definitely a point of reference. Now, with that said, what we need to do is identify 2 things when we draw our graph. Where are the values that we can use? And then what can we do with the 4? Okay. Well, let's start with the values, right? So on my number line, what numbers are bigger than the 4? The ones to the left or the ones to the right? To the right. So that's why we like number lines. I think most people are confident with saying, hey, I can just shade over here and I'm good. The reason this is helpful, though, is visually we're saying any number I can think of that lands over there will work. Okay. Another way to kind of do a quick check if you're not sure, though, is we'll look over here in the space that has nothing, right? What number is over there? All right. There's no shading over here, but there's a 0, right? Is 0 bigger than 4? No. If you get stuck, no, that's a great way to kind of compare. Hey, 0 is not bigger than 4. So that's how I knew to shade on the opposite side of where the 0's at. Okay. And I would definitely say get comfortable plugging in something like the 0, what we call just a little quick test value. Okay. Because there's going to be times where you might have a number you're not sure about, or you might have two different numbers to work with, right? We dealt with absolute value and quadratics, which give us two different things to work with, right? Not just one. As we look at this, though, what can I do with the 4 is the last question we do have to take care of, right? And the two ways that we'll highlight that is you could have just kind of an open circle or a circle that we're just going to shade in. All right. The open circle is going to be used whenever, like, hey, this is a point of interest, but it doesn't help me, right? It's not a part of my solution set. So here we would want to use the open circle, right? Now, another way you'll see this is with parentheses. Okay. So watch out for parentheses there. That means then just know that you would use this with greater than or less than. This means then over here, this would be greater than or equal to, or less than or equal to is when we use that, the circle that we're going to shade in, or solid dot.
So the open dot is the greater than or less than?
Yes.
Okay.
That's our separation. Now, with that said, though, make sure you see here, though, that if you use parentheses for the open circle, we're going to use square brackets for the what we're going to call the closed circle. I like to use the circle. So when I'm doing this, if you see me graph by hand, this is what I'm going to put. Pearson might use the parentheses and bracket approach, but it's the same thing. Okay, same thing. The reason I like to do this, though, is because when we start getting to where we have two variables, the point is more appropriate. You're not going to put parentheses or brackets on a plane when we got two different variables working with. Okay. With that said, though, this is going to be just the graph of our solution. Okay, you didn't have to put all the extra stuff. Just, hey, put the 4, put the circle, and shade the correct side, and you're done. All right, but it's a great way to visualize the fact that we have a lot of solutions here. It's not just one number. There's actually an infinite number of solutions. Okay, so that's why I picked on square root of 39 or 19 thirds, numbers we wouldn't necessarily jump to that are bigger than 4, but they are. Okay, with that said, though, what we also have then to help with this is what we're going to call interval notation. Now, this is going to be what we use a lot of, just so y'all know. So on the test, I would be like, hey, when you solve this inequality, give me the solution set in interval notation. All right, and we're going to use this a lot this semester, but it's just a mathematical way to kind of get a quick understanding of what we're working with. And it follows just reading from left to right. So the graph is definitely a helpful place here, right? So as I go from left to right, what's the first thing we see, right? Remember, there's two things that we can see: the points that we're interested in and the shaded area. So as I go from left to right here, going from the left into the right, and the first thing I run into is actually the point of interest, right? Now, can I use 4 right now? Is 4 a solution to my inequality? No, right? Because we had greater than, not greater than or equal to. But it's still that point where we say, hey, I'm going to start at 4, right? Going from left to right. What should we use then as we continue to the right when you recognize it'll never stop? Infinity, right? So mathematically, infinity means, hey, this is going to keep on going. I can't do anything about it. It does not stop. So that's where the infinity symbol is going to come in. Now, what did I put in between those two things? A comma, right? And what we're saying is start, stop. That's what that represents. I start at 4, and technically we don't stop because infinity means it keeps on going. Now, with that said, though, can I plug in 4 and get a true statement? Is 4 greater than 4? No. So what should I put on the 4? The parentheses, right? Which is why I made sure to point out over here in the bottom, that's what we were looking at, right? So if you did your parentheses here, no big deal. I wouldn't make an issue with that. Like I said, just know that when I get to 2 variables, that's what's more going to look like. But when I get over here, though, can I plug infinity? Well, what's infinity minus 7, though? All right, infinity is just a concept, right? It just keeps on growing. It's a big number that we can't actually count to. So understand that since that's a situation there, we'd also always put a parenthesis on the infinity. Okay. Those symbols, though, are very important because the symbols tell us how to handle the values, right? So the 4, yeah, I start at 4, but I do not include the 4. That's not a part of my solution set, but it's still important because 4.00000000001 is a part of my solution set, right? And I could put an infinite number of zeros there as long as I put a 1 at the end. It's a part of the solution set, okay? But for itself is not. That's what the parentheses tell me. And then as I just mentioned, infinity is not a number, it's just a concept, right? Now, as far as dealing with infinity, it's more of us just acknowledging that's going to keep on going forever, right? You need more advanced math to find ways to get around it sometimes, okay? But for our end, that we want to look like, hey, it's just going to keep on going. So everyone go with that? Any questions or concerns with this first one? Now, like I mentioned here, we have to be careful because there are some exceptions that we deal with. I give us something that looks like this. All right, so we have 5 minus 2y is less than or equal to negative 13. So as I mentioned, when it comes to solving inequalities, know that follow all the rules we did before, but there's going to be one exception you have to watch for. We're not working with something that is equal on both sides now, right? The direction of our symbol matters big time. There is a big difference between that and that. One is less than or equal to each other, and the other one is greater than or equal to. Okay, and we have to make sure we're careful to recognize that. Now, what I'm going to do is I'm going to solve this 2 different ways. All right, so what would someone do first when they solve it this way right now? You subtract 5 from both sides. Anybody disagree with that? So we're all good if I get here? Now, that's the way that I showed y'all to do it, right? Y is already by itself on one side, so let's get the constant term out the way. But what would we have to do next? We would have to do some division, though, which would require the changing of signs, right? That's the important part, though. But here, understand, we got to divide by -2 on both sides. This is where an alarm needs to go off, that we have to say, hey, I got to be careful, alarm. But this goes back to like we talked about with the quadratics, right? Or the rationals, that there are certain things where you got to put something in place to remind yourself, like, hey, if I have this, what is it that I should be doing with that fraction? What's the alarm we had here? Well, we might get the multiplication, but what did I recommend doing first? The restrictions, right? The denominator can't be 0, which means here, just kind of make sure we note that I can't use 3, right? The other situations we ran into would be like, hey, 2x minus 5 equals -3. Or absolute value of y minus 2 is equal to -14. What's wrong with both of those? They can't equal negative. But is there anything to stop you from moving forward? Oh, you could square both sides on that radical. -3 squared is 9. There's nothing to stop you there. Just like there's nothing that forces you to state your restrictions here, right? These are examples that you have to have a kind of a warning in place that says, hey, state my restrictions right off the bat so I don't mess with it. Square roots, absolute values, no negatives. Don't forget. Okay. With that said, then what we need to do here is have our alert that whenever I'm solving an inequality, I'm going to have to change my signs, as you mentioned, that we have to be careful with that. Now, how do we know that? Well, watch this. What if I change how I solve it? I'm going to do something that's kind of out of the order of what we normally do, and I'm going to add the 2y to both sides. That's not what I recommend doing, right? As I said, the y was already by itself. So the first way, subtracting 5, is exactly how I would have done it with the equations, right? But the reason I want to show this real quick is this will give us 2y minus 13. And when I add the 13 to both sides, what happens to both the numbers? They're both positive. However, do they say the same thing? That's what we have to be careful of, right? One says the y is less than or equal to the number. The second one says the y is greater than or equal to the number. The key is you don't have to do it this way, but that's one way to be careful that you don't make the error, right? Force your variable term to be positive. And you'll see here that we should get 9 is less than or equal to y, which we can rewrite as y is greater than or equal to 9 if we prefer. Over here, as long as you remember, anytime you divide or multiply by a negative number on both sides of an inequality, that you have to change the inequality symbol yourself.
Say that again for me.
I said, anytime you're solving inequality and you have to divide or multiply by a negative value, you need to change the inequality yourself. Like this has to be like, I need to do it myself. There's nothing that's going to tell you to do this. This is your recognition that, hey, I just divided by -2, change it from less than to greater than. Right? But if as long as you remember to do that, guess what? Uh-oh. Yeah, so like you saw over here, I didn't do it over here. It's only when it's negative. But when I did it that way, guess what? Aren't all of these the same statement? Now, why is that an issue? Right? Well, it's going like with what negative values are, right? This is negative right now because it's down. It says it's off, right? But all the lights are on. It's now up, right? It's in the positive setting. But as I walk over here now, let's see if I get the right one the first time. What's going to happen when I take this one, which is up, and push it down? Up. See, I picked the wrong one. Come lights back on, right? So we see the signed issue there that, hey, when I divide by a negative, one side changed to represent that negative, right? And the other side had to change as well. It affects the number line in a big way, right? With an equation, if the number line changes, no big deal because it's equal to. Both sides are the same all the time. But with inequality, what we see there is we just took all the negative values and made them positive. All the positive values we made negative, so we rotated the line that we're working with. And remember, as we just looked at here, we're not looking at a specific solution, but we're looking at a whole section of values. And that gets turned around when we're dealing with that. So we have to be careful with how we handle it. Okay. Now, with that said, as long as you remember to do it, you're perfectly fine. If you don't like having to remember that, just remember there's ways to get around it and not to have to worry about it. Okay. Questions or concerns there? All right, let's try one on our own. Oh yeah, I guess I should have done that. My main thing was the steps, but just to make sure we do it. Now, what am I going to put first then based on what we talked about? Why are we doing a closed circle, y'all? All right, we have the equal to portion, right? Does everyone see that? Which way do we want to shade from there? To the left or to the right? All right, is 0 greater than or equal to 9? So if I plug that in, 0 is not greater than or equal to 9, right? So we actually want to shade to the right. Gotcha. Now, as far as the interval notation, we put 9 comma infinity. What's the difference here, though? Because we can use a 9. This is where you would see the bracket used, okay? Now, make sure you read the directions on the homework, okay? The homework will tell you what to put. Look at the practice test, though, as far as what to put for Thursday's exam. The practice test, I don't change it to. The directions might be a little different on the paper test just because I'm writing it up. But make sure you understand on the homework, sometimes it says use set builder notation, so they just want you to put y is greater than or equal to 9. It means you solved it properly. Is that clear to everyone? There might be problems with graphs. Make sure you know how to pick the right graph. If it asks for interval notation, though, remember that's that last piece that I put here at the bottom. Okay. Any questions or concerns? Now, remember, the whole focus of this was just to make sure we're careful with how we handle our negatives. Okay. That's only when we're multiplying or dividing by a negative value, though. So keep that in mind. Adding and subtracting is not the issue. It's multiplying and dividing by a negative.
These are just two different ways of how to get between.
Yeah, as I mentioned over here, I did this one to show that I made that positive.
Okay.
By adding to both sides.
Okay.
So when I got down here, it was +2 and +18.
Okay.
So the division here, I could just divide them. Good.
Okay.
Just know it looks a little different,
Okay.
but it gave us the same thing. But if you choose to do it this way, you're responsible for doing that change. Okay. Now, remember, some problems we can kind of see ahead of time. You can avoid the negative, but as you saw here, I set this one up to where we were forced to deal with the negative, okay? Oops. Ooh, excuse me. All right, another problem for us to solve. Ooh, I walked in after I took attendance. All right, thank you, Chris. I got you. AJ, right? I got you. Anybody else I missed? Now, the one thing I will say about these problems, remember, I could do it just like we did linear equations, right? There's a variety of ways that I can have simplification involved, okay? So keep that in mind. The difference here is not the solving completely, right? As we saw, there is one difference. The difference that we're focused on, though, is the interpretation, what to do when we get to that last step. All right, so I see a lot of people starting with that first step of doing what? Distributing. I did see that a lot as I walked around. Just be careful after you distribute to combine your like terms. What did someone do from here, though? You did the 5M. You did the 3M, right? Now, based on my recommendations, what did I say we should do? But I would say start with the M's, right? But the reason you did 3M was because what's 5 minus 3M? 5M minus 3M. 2M. Is it wrong if you subtract 5M from both sides? Not at all, right? But just make sure you understand there's a reason here why this is definitely important. As we just talked about, we're trying to avoid having to deal with this. So here's a situation where you can choose. It doesn't matter, as I just showed you, both sides should give us the same solution. We should not get different solution sets here, okay? But my recommendation from the beginning was to do minus 3M on both sides, because when I do that subtraction, hey, I'm gonna have a positive M, specifically positive 2M. That's my main thing here, is that this is a positive coefficient on here, on my variable. Now here, though, we would add the 8 from both sides. If you did it the other way, though, you would have subtracted 2 from both sides, okay? So make sure we see some differences here. Specifically, how many of you had negative 2M less than negative 10? Is it wrong? No, but what we do next will determine what's going on, right? Here, the way I would have done it from the beginning, recommendation-wise, like I said, it's not the only way to do it, just my recommendation. You didn't have to worry about switching anything. Just divide by 2, you're done. M is greater than 2. If you need to rewrite it so that you see it, just make sure that it still shows that M is bigger. But when you divided, did we make sure to put? You did switch it. Then do we have any issues? Not at all, right? So as long as we remember to switch our signs, we're good. Now, 5, yeah, y'all, there's been a lot going on in my house. I'm sorry. I'm tired. We're all good here, though. Any concerns with where the 5 is coming from? Only one person divided by -2, though? Or you did that way? So are we in agreement, though, with the M greater than 5? No. Now, you'll find that like on the homework, when it tells you to use set builder notation, which means put in M greater than 5, it might want you to put the M first, but it should not matter. It should not matter. They both, on the test, if you stop here, as long as you write your solutions correctly, you're fine, right? Because as I mentioned, what are we going to use on the test? Interval notation is what I'm going to expect on Thursday. Is that clear to everyone? With that, then that means if you need to draw your little number line with the 5 there, let's put the 0 over here, right? 0 is not bigger than 5, right? So make sure we shade the other way. Can we use the 5 though? Is 5 bigger than 5? No, right? It's not. So that's where we're going to put our open circle here. That would be one way to write our solution. Here's another way to write our solution. And remember the last way we talked about, which is what I'm going to expect on Thursday. Parentheses 5, comma, infinity, which is what we call interval notation. The key there is, remember, we starting at 5, and then we can go to the right. So if you ever need to, just kind of put a little hint up there on your number line that positive infinity is on the right, which means what's on the left? Dang, I guess I should have tried to do one differently, sorry. But negative infinity would be on the left. Now, what my plan is for the rest of the week is kind of do an introduction for dealing with absolute values, but I'm not going to put an absolute value 1 on the test. Is that clear to everyone? All right. It'll just be kind of a quick introduction. My main thing is that if you can do this problem here, just be prepared for some outcomes. So tomorrow I'll spend a couple minutes closing out some of this stuff just to show you different perspectives, because we can have identities, we can have contradictions and conditionals with inequalities, just like we saw with equations, okay? But the rest of tomorrow will be focused on making sure if you have questions for the test on Thursday. Wednesday, questions for the test on Thursday. If you don't come with questions, though, I'm not going to do anything. So you have to come with questions. That's how a test review works in my class. You have to bring me questions, and I will work those questions out. Now, if you're not sure where to get questions, where did I say we should have already went and looked at? The practice test, right? Is the practice test hard to find? Well, it is if I didn't publish it. Did I publish it for this class? Okay. So I believe I put it right at the top of week 5, right? Week 5 should have practice tests right at the top. Okay, that link is not going to count to your grade. There's no bonus points for doing it, but where does it help you? It gives you an idea of the problems I've put on the test in the past. Now that's my online test, right? So my online class sees something more similar to that. We're going to have paper-based. But the key is here, just like I would in an online class, that sheet of paper is what matters, right? How we're writing our work, okay? The advantage y'all get is you get space on the paper right next to the problem to write it out. That's the only difference I do, okay? For our class too, though, I take a couple problems off if I haven't mentioned that. So when you look at that practice test, no, I can't put all those problems on in our face-to-face, right? Because that's an hour and a half for their test where y'all only get an hour 15. So I do keep that in mind, okay? Any questions though with inequalities I clear for somebody? All right, then. Well, have a good day. I will see you tomorrow where we will, as I mentioned, close this out and start our review.